Now it's your turn to solve a system of linear equations by graphing. Please pause the video, try to complete this example on your own in your notes first, and then return to the video once you've completed it as best you can to check your work. To solve the system 2x plus 4y equals 8 and negative 3x minus 6y equals 12 by graphing, we will first want to put each equation into slope-intercept form. We'll begin by labeling L1 as our first equation, 2x plus 4y equals 8. To put this into slope-intercept form, we want to subtract 2x from both sides, giving us 4y equals negative 2x plus 8. We will then divide both sides by 4, giving us the equation y equals negative 1/2 x plus 2. We'll now repeat that same process for the second equation, line 2. L2, or line 2, starts out as negative 3x minus 6y equals 12. Our first step will be to add 3x to both sides, giving us negative 6y equals 3x plus 12. And as a final step, we will divide both sides of the equation by negative 6, giving us y equals negative 1/2 x minus 2. Now that both equations are in slope-intercept form, we're able to judge possibly what scale we will want to use and where we might want to center our axes. We'll begin the graph by setting up the axes with the axes themselves drawn with a ruler, labels, scales, and arrows on at least the positive ends. On the green equation, we can see our b value is 2, telling us our y-intercept will be the point 0, 2. From there, we have a slope of negative 1/2, which means down 1 to the right 2, or up 1 to the left 2. With those 3 points lining up nicely, we can see they go downward, which matches our negative slope that we would have expected, and we'll finish by drawing the line that connects those 3 points. We'll make sure we finish off that line by adding arrows to both ends and labeling that as L1. Now turning our attention to the second line, the second equation, y equals negative 1/2 x minus 2. We'll take that negative 2 as our starting point on the y-axis at the point 0, negative 2. And from there, we will use the slope of negative 1/2. Down 1 to the right 2, down 1 to the right 2, or up 1 to the left 2. Again, the points that we drew line up nicely, so we'll grab our ruler and we will draw that line. Again, we will remember to put the arrows on both ends and label that as L2. Now that both lines have been graphed, we can turn our attention back to the original system and the original question. We were looking for a solution for this system. A solution for this system is an ordered pair, an xy point, that works for both equations. Well, if it's going to work for both equations, it's going to have to be on both lines. What we know, based on the slope-intercept form, is that both these lines have the same slope of negative 1/2. Two lines that have the same slope but different y-intercepts are parallel, and parallel lines will never intersect. Again, we're looking for a point that's going to fall on both lines, but we also know the lines will never intersect, therefore there is no point that will be on both lines. What does that mean for our system? It means our system has no solution. We can conclude our work in one of two ways. We could write the statement, there is no solution, or we could use the formal set answer that the solution set is the empty set. It is important to recognize that anytime you're solving a system of linear equations in two variables, and they give you parallel lines, there is no possible way that system has a solution.